Good afternoon, everyone. Today, I will talk about direct versus different method to determine amino acid digestibility in ingredients fed to pigs. Standardized ileal digestibility values are additive in mixed diets because it accounts for basal ileal endogenous losses of amino acids and therefore the SID is independent of dietary amino acids. There is two methods to determine the digestibility of amino acids, by direct or difference procedure. With the direct method, the diet is formulated such that all amino acids is supplied by the test ingredients. However, in this method, if you test cereal grains, higher fiber or low palatability ingredients, sometimes you have a concern if low amino acid content in the diets may affect the SID of amino acids. And therefore, in some cases of ingredient evaluation, the test ingredient cannot be fed for a long enough period of time to determine the digestibility of amino acids. And in this case, we can also use the difference method. In this method, the diets are formulated with other basal ingredient in addition to the test ingredient. On this method, we have an extra diet with basal ingredient, and therefore the SID of amino acid from basal ingredient need to be subtracted. However, the SID values obtained using the difference method are usually associated with a greater standard errors than if direct method is used. But data that compares direct and difference method to calculate the SID of amino acids for the same ingredient have not been reported, and therefore we want to conduct this experiment to test the hypothesis that the SID of amino acids in cereal grains and fiber-rich ingredients obtained using the direct method are not different from values obtained using the difference method. Moving on the Mathieu method, this experiment used 16 cannulated barrels with initial body weight in average of 69.5 kilograms, allotted into 8 experimental diets with 4 periods and 8 observations per diet, and 5 days adaptation and 2 days collection. Talking about how we got the SID values for the two methods, in direct method, diets had the test ingredient supplying all amino acids content in the diet, and therefore, values for SID of amino acids calculated for diets also represent values for the test ingredient. For the calculation and difference method, we had a basal diet and a test diet, which was formulated to have mixed diet with basal ingredient and test ingredient. The first, it was the calculated the values for the diet, and then the proportion of amino acids that were supplied from soybean meal was subtracted from the SID values in the diets, then it was obtained the values for the test ingredient. 4 diets were formulated based on soybean meal, corn, wheat, and wheat middlings as the only source amino acids. And then 3 additional diets were formulated mixing soybean meal and corn, soybean meal and wheat, and soybean meal and wheat middlings. And the last diet was a nitrogen-free diet that was used to estimate the basal endogenous losses of amino acids. In this graph, in the blue bar, we can see that the lysine, methionine, threonine, tryptophan, isoleucine, and valine were below the requirements recommended by NRC. However, if you take a look in the orange bar, the difference method, we can also see all amino acids was almost of the requirement or above the requirement recommendation from NRC. The same way, if you take a look in the percentage of the requirements and amino acids and wheat diets by direct method, all amino acids were below the requirement. And the difference method, we had all amino acids to meet the requirement or above the requirement. Also, it was similar for the wheat middlings diet. The direct method, all amino acids were below the requirement, and the amino acids in the diets from difference method met the requirements or above the requirement. Moving on to the results. This graph shows the SID of amino acids in corn comparing values obtained from the two methods. In the orange bar, we have the direct method, and blue bar, we have difference method. For almost all amino acids, we did not observe any difference between the two methods. However, the SID of tryptophan was greater in direct method than in difference method. Similarly, the SID of amino acids in wheat obtained by direct method or by difference method, we did not see any difference between the two methods. Likewise, the SID of amino acids in wheat middlings for most amino acids, we did not observe difference by direct method and difference method. However, again, we can see that the SID of tryptophan calculated by direct method was greater than the difference method. So that difference we observed for SID of tryptophan may be explained that the concentration of tryptophan in corn and wheat middlings is really low, and therefore is difficult to analyze. So if any mistake happens, can underestimate the contributions of tryptophan that was supplied from the test ingredient. In this graph, we can see the standard errors of means between the direct method and difference method. As we expected, the standard error of means was higher in difference method than in direct method. And this can be explained because all errors were assigned to the test ingredient. So, if difference method is used, the results will be most accurate if the greater proportion of amino acids comes from the test ingredient. Based on the results, we can conclude that the SID of amino acids are not different between two methods. Also, the SID of amino acids below the requirement does not affect the digestibility, and both methods may be used to generate SID values for amino acids. With that, I would like to acknowledge Evonik for the financial support for this experiment. Thank you for listening, and if you are interested to know more about our research that have been conducted, you can visit our website at nutrition.nsci.illinois.edu.